Next step will be to put all of these bodies together. We'll minimize both these sections, create a new one, and we'll call this core plus baffles. Do File, Save, and close this cross section. We're going to use our Boolean clean compound block. So this Boolean union clean will capture this. And we'll open up both of these list inputs. All this compound block or custom block does is one final intersect at the end to remove what we call bleed over. I won't go into that here, but we have other videos discussing that effect. We can look at the information of this compound block, and at the bottom we can scroll down and see what the two different lists are going to require. So this input bodies are the main input bodies that we want to union together, and then trim bodies are the ones that we're going to use to control the bleed over and ultimately intersect with. So I know I'm going to want a blend radius between the baffles and the hex core, so I'll make this a variable. And the first thing that happened was this got turned into a scalar value. Maybe we want to manipulate it via ramps or some other kind of field. So we can click this drop down arrow and select scalar field instead. And that's going to turn this blend radius into a field. And we'll call this baffle to core radius. And we can presume maybe that I want this thickness to be have the same multiplier as the baffle thickness. So I can put multiply again. I'll grab my TPMS thickness. Now in this example, we're using a scalar field as the TPMS thickness. So we can turn this on, see by the color and the symbol that they're both scalar fields, as opposed to with the baffle thickness was just a scalar value. So we'll grab the TPMS thickness, and we can just put that same multiplier of 1.25 for now. We can make this operand a variable and tie it to the baffle thickness as well if we want them to always be the same. We'll minimize both of these, and we'll go ahead and put our input bodies in. So for this case, we're going to want the hex core. So we're going to filter out hex core. We're also going to want the hot inlet baffle, the hot outlet baffle, cold inlet baffle, and cold outlet baffle. So this list is complete. And we'll go into the trim bodies. And in this case, we're going to trim with just our design space. So if we turn on the design space really quick, we want to keep everything within the design space, and any bleed over we're going to trim away. So we'll isolate this value, and we have a blend radius between the baffles and the hex core. We'll make this a variable, and I'll call this hex core plus baffles. And real quick, just for fun, I'll show you that bleed over effect. So I'll select a Boolean union. I'm going to delete this list. I'm going to put the list of bodies that I want to union together, and I'll put a blend radius of 2 millimeters just to exaggerate a little bit. And we'll see that we get this bleed over effect that happens when we union implicits together. If we continue to decrease this to, let's say, that value of 0.625, we'll still get a little bit of a bleed over. It'll be less pronounced, but this Boolean union clean is just going to keep the fillets where we want them, primarily inside the structure and not outside. So if we turn this Boolean union to 0, where we have no fillets, and turn this on we're not going to have a blend radius between these two bodies. Moving on from here, we'll minimize the hex core and baffles. I'm going to hit Z to zoom back out. And the next step is going to be unioning together the shell and solid bodies. Sometimes we need to take into account order of operations when we're unioning our parts together. For this operation, we won't need to do our Boolean clean. And we're going to put all of our solid bodies together. So we can drag our shell into the first input, our outlet pipe, and we can either click this plus sign, or we can drag and drop and wait for this blue highlight to pop up just underneath the 1, or maybe in between the 0 and the 1, and we'll just drag these and add them to the list. And in this case, we'll just make this a blend radius of 1 millimeter. We'll make this a variable, and we'll call this shell plus I/O ports, inlet outlet ports. Minimize this, and now we'll put them all together into the final part. We'll use the Boolean clean again to deal with the bleed over. We'll assume the same blend radius between the core and baffles to the core and shell. And in this case, our input bodies are just going to be the hex core and baffles and the shell plus I/O ports. Our trim bodies in this case is going to be a longer list. It's going to be our design space and each of the solid bodies that we used to make up our part. So that's going to be our top dome implicit, the implicit shell, the oil outlet pipe, and the oil inlet pipe. We'll isolate this, make this a variable, and call it final part. Look at a cross section, let it render for a second. And see that we've filleted between the shell and the main body. Now, presume we want to have this be its own blend radius. We can simply remove that variable, make a new one. We'll still want to, let's say, tie it to our TPMS thickness, but maybe we want this blend radius to be 50% larger. Close our cross section, minimize our final part, and save our project. So in effect, we've created our two fluid domain heat exchanger.